Hello and welcome to Digital Labs for Consumer Packaged Goods, transforming your lab workflows and resource optimization. My name is Tom Muth. I'm the Global Strategic Industry Development Director at Dassault Systems, and I'll be joined today in our presentation with Stephen Hayward, who is the Technical Marketing Director at Dassault Systems. First, a little background on Dassault Systems for those of you who are not familiar with us. Dassault Systems is a purpose-driven company. We're a technology company combining art, science, and technology to drive a more sustainable world and more sustainable operations. Our company is made up of over 20,000 people around the world, and we're a long-term driven organization. We're majority shareholder owned, investing a significant portion of our revenues back into R&D to help companies drive sustainability. We go to market through partners around the world, both software, technology, consulting, and systems integrators, as well as work very closely with education and research organizations. And we're very pleased to say that we're in all industries around the world. We have over 290,000 customers in a variety of industries, including consumer packaged goods, home and lifestyle, aerospace and defense, life sciences, and other industries. And we go to market through what is called the 3D Experience platform. This game-changing platform helps drive companies in their sustainability all the way from design through manufacturing and supply chain. For consumer packaged goods, we have several solutions for the lab. And we're going to be speaking today around the lab in consumer packaged goods. And in the lab, there's several challenges that we'll talk about. But our solutions cover the gambit from formula management, whether it's tracking formulations, dealing with regulatory data, managing costs, to laboratory informatics, helping you sharing science, intelligence between the various teams within the lab, to data modeling and simulation for modeling and building a product and property reductions, and starting off with molecular modeling, helping you discover and validate novel chemicals and catalysts and recipes for development of new goods to go to market. Our goal is to help you improve your innovation and sustainability through streamlined material selections, focused lab processes, digitized lab processes, and helping you integrate that production data along with model building and machine learning to create the lab of the future. In CPG, there's a specific evolution going on today. The renewed business drivers, especially what we're seeing today, is increased pressure at plants and labs. And it all starts with the new consumer. We've seen the new consumer trends really take off in the last year or two, with consumers looking for products, the expansion of SKUs, which CPG companies are managing, and the change in the consumer trends of shopping from home, looking for sustainable lifestyles, and having a connected shopping experience. This, of course, drives significant pressure within your business. The margins, of course, are very tight within consumer packaged goods. Dealing with high volume and low margin business is a challenge in and of itself. The lab is an important part of efficiency in helping drive that margin to an acceptable level. Companies are dealing with uncertainty in their demands, and we're seeing consumer spending power being challenged as the economy starts to improve. There's also a sustainability mandate really across all industries, but that couldn't be more important in consumer packaged goods, where brand equity and business model protection is important and paramount. There's also a drive for science-driven innovation. The ability to speed and bring new products to market is very critical in consumer packaged goods. I'm not telling you something you don't already know. But we're also seeing in the marketplace a shift in category spending towards different, more sustainable products, as well as more healthier options. And we see a lot of startups coming to market through their ability to be more agile, and also companies looking for more connected experiences between the consumer and the actual manufacturer, beyond just the retail outlets. Production complexity is always a challenge within consumer packaged goods. As you can imagine, there's billions of goods with quality mandates that have to be achieved to ensure brand equity. New products need to come through those same plants, and capacity and efficiencies are heavily important in driving those new categories of goods in a timely fashion. And of course, regulatory compliance is an ongoing mandate within any consumer packaged goods organization, and really any organization across any industry. And so health now becomes a new politics, really, of a company's mantra in terms of being able to go to market and protect their brand equity. And so consumers are going beyond just the regulators today, demanding that there be transparency and visibility into the quality of a particular product, whether it's the sourcing of that product, whether it's the production of the product and the materials used, or the sustainability aspect of that particular product. And as a result, we see supply chain volatility as well, increasing that pressure. You know, being able to manage for new risks, looking for different sourcing strategies, different materials. All of these drive increased pressures at the plants and also within the labs, because the speed at which we operate today is much faster and even more tightly controlled, and the expectations from consumers are even greater. You know, with this, the lab itself is put under a lot of pressure. Within that pressure, we're seeing labs specifically in their dynamic of not just working with R&D, but then also working with production, the labs being put under tremendous amounts of pressure. And the pressure comes from late tests. We see backlogs on the rise as new companies and existing companies are driving new products to market. Lab costs are steadily increasing, the cost of labor, the cost of materials, the cost of equipment, and there's significant pressure, as I mentioned before, on costs and target dates. And then always a reduction of lead time is an increased pressure onto the lab. In order to do that, it's important to have a digitized lab and an efficient lab. And of course, all of that needs to be done with the regulatory traceability and compliance in mind. So with that, I want to talk about some of those required changes that's required in the lab for consumer packaged goods. And I'm going to switch off over now to Stephen, who's going to talk about that and a little bit of within the lab and what we do. Stephen?
Thank you, Thomas. So as mentioned, I'm going to talk a little bit about how these pressures on the lab are driving the changes that we need to see in CPG labs, and then going forward, how we sort of address that and the solutions that we can help you with. So in the lab, we're really looking to support the workflow and documentation efficiency of the scientists that are working there, right? So to make these workflows more efficient, to simplify their day-to-day processes and make sure that we're speeding the processes that they're performing. At the same time, we have to protect the intellectual property that they're creating. So making sure that it's stored in a secure location and standardizing it so that we can reuse it as necessary in the future. And that also helps us to connect the different parts of the organization, the different labs that are in place all around the globe. So you're connecting your research, your development, and your quality labs, and making sure that the information is able to flow seamlessly through those as necessary. And that's something that helps us to reduce the cycle times as well, right? So you streamline the workflows within each lab and make sure that that they're not becoming a bottleneck. And then you're also streamlining the flow of information between the different labs. And By capturing the data in a single place and making sure that it's consistent at all times, that also helps us improve the compliance and traceability of the data across the different labs. So it's very easy to track down any issues. It's easy to compile reports and put together things like your bill of materials. And so all of these things together are what enable us to increase the productivity and efficiency in the labs. And it helps to make sure that they're not a bottleneck and to get products to market faster. And that obviously helps your bottom line. So the theme here is really all about integrating everything together, standardizing the data, and leading towards operational excellence. And so from that, I'm going to talk about how we help with that in the lab with the specific solutions that we offer. So let's take a look quickly at the major steps in the lab workflow. So the lab work has to be planned and managed, and that means that the work like the execution of tests is requested, and these requests are then reviewed and scheduled and confirmed which resources need to be allocated for them. Those resources can include things like materials and equipment for testing, the personnel who are actually going to execute the work, and the samples that are going to be tested. The methods and procedures are developed and adapted if required, and they need to be managed as well. These methods and the specifications will be used for the execution of the lab work, so where the tests are prepared and performed. And then the raw data are collected and compiled, and the results are interpreted for reporting. And these reports can span everywhere from things like certificates of analysis to documents for research that might result in the need for further testing. So with all of these moving parts, any inefficiency can slow down your overall process through the labs, and that's what drives up your operating costs and increases bottlenecks. And so we're working to modernize this workflow. And as you see here, all of the screenshots that have appeared are pieces of our lab solution where you're managing the recipes and the execution of work around the lab. You're dealing with the samples and the inventory and equipment throughout the lab and integrating that into the workflows. You're able to execute the tests in a standardized fashion, and then you can analyze, interpret the data, and figure out what needs to be adjusted as you move forward. So one of the things that we manage is a unified content layer so that all of the methods and information is built around industry standard taxonomies and ontologies. So this helps you build the methods in a standardized fashion and built on an S88 industry standard, which also helps with tech transfer as you move forward into manufacturing. We have these scientific collections of information so that you can apply them to different areas of the lab, from chemistry and biology where necessary, all of your scientific images and text collections. So these can be built out according to the needs of your individual labs. And we have catalogs of materials for registration, and the different chemicals and things that you will bring into your lab and use in the inventory management as well. So all of the stuff is available across the lab informatics solutions, and that's what helps make sure that it's standardized and applicable wherever you're using it. We also, as I mentioned, manage the different lab assets around all of your labs, so you can pull data directly into these solutions from the instruments itself. So you can acquire data from serial and file-based instruments, as well as database storage instruments like CDS. We have libraries of equipment and instrument definitions so that it's easy to get up and running with new equipment, instead of having to define it yourself for each piece that you add into the system. And then as you're using the equipment, you can track its use and the consumables that are being used as well in the electronic logbook. So that means that you understand how long an instrument has been in use, when it's likely to require cleaning, and that helps you plan out for maintenance in a predictive manner. And this also then ties together with your inventory management as well, so that you understand the consumables you're using. For our recipe and method management, as I mentioned, we have a standardized interface for it. You can build recipes in sort of a drag and drop manner based on standard activities that are defined in advance. And these are built along with this S88 standard, as I said, so that this helps with tech transfer as you move forward into manufacturing. They're both procedure and process flow views, so it's easy to visualize how you're building out your procedure and the different dependencies of the steps that you're putting in place. And it's all in a web-based, web browser-based interface, so it's easy to transfer across different screens and computers, and it's always able to stay consistent. And again, this integrates with the material management so that as you're building out a procedure, you're defining which pieces of equipment are going to be used in a given procedure, and that makes it very easy for the user to use, as we'll see in our next step, which is about data capture. So this is going out into the lab and performing these tests in this stepwise execution manner. And so this enables you scientists to move around the lab very easily and follow a procedure that's laid out for them and make sure that that's happening in a consistent manner so that the tests are always performed in the same way according to the procedures you've laid out in advance. It can happen in a stepwise fashion so that you have the ability to enforce limits and tolerances on the pieces of information that the scientists are capturing. And so if something falls outside of those limits, that's when you know that it needs to be reviewed. And so it's set aside for automatic review. If things are within the limits and tolerances, then it can be automatically approved. And again, this integrates with your materials management so you understand what consumables are being used and how much is left in your inventory. We are also able to sort of plan out and schedule the tasks that need to be assigned. So this is the task planner where you can prepare and assign the different batches of solutions that need to be tested. This is also where you can assign the calibration of your lab instruments, and so what needs to be done at different times, and then who it should be assigned to. And this is something that Thomas is going to talk to in a little bit as well, on how we expand in this area. But it also helps us to monitor which tasks have been done, which are outstanding, and that's the first step into reviewing the plan of the lab and what is still remaining to be done, what's on target, and what's falling behind. And so with that, I'm going to hand it back over to Thomas to expand on those topics a little bit further.
Thank you, Stephen. I want to talk further about the planning and scheduling aspect within the lab, and specifically planning and scheduling of lab work. And lab work scheduling affects all these different departments: R&D, product development, and the quality control labs. And today, there's a lot of different activities for each one of these groups in the lab, but they all share a common goal across each of their functions, which is to deliver on time, in schedule, and with maximum efficiency. And doing that, of course, with quality. And it's important to have collaboration between all of these different departments because they all share those similar goals. They also share different methods and have handoffs between each other in terms of the lab work all the way through from development into production and throughout production as part of quality control checks. So it's critical to have a more finite view of the resources, the people, and equipment in order to have an accurate schedule and deliver on time. In today's world, though, there's a lot of poor planning and scheduling processes and tools in place, and you may be have digitized part of your labs, you may be in a more manual process, but typically what we see is a lot of companies today have poor planning and scheduling processes still in place. Excel, of course, being the tool of choice, and quite complex Excel at that. We see a lot of companies today still requiring manual data entry in the process, which of course leads to high risk of human error in transposing data and test data. that information tends to be very static. It's not dynamic as new constraints or issues come up in the lab. It tends to be also pretty time consuming, which leads to pretty poor productivity within the lab, and also very non-collaborative. People can't work on that same schedule in conjunction, and planners and schedulers need to work in isolation and finally pull a final schedule together. And as we see today, companies are seeing the impact of that poor productivity in shorter time to market, maybe holding up production as lab results are being waited on, lengthening the time to introduce new products if there's new formulas that are needed to be validated and created. And all of these point towards a need for a more robust planning and scheduling solution. And so the need for digitization in the labs in the domain of planning and scheduling is very clear. We need to anticipate and control the different load fluctuations within the lab, whether it's materials, whether it's the lab equipment, whether it's specific certified labor resources, and do that not just in the short term, but also midterm, and not just within one lab, but across different laboratories as well. You may have operations that are you need to send tests out or do work on in one lab and collaborate with another lab in a different location. Of course, equipment's very expensive and not always working, so there's a need to maximize the asset utilization in play and know what's available and deal with those constraints in terms of production scheduling and planning. And of course, we need to ensure that the right scientists and technicians are available and to do the job at hand, to ensure that they have the right certificates to conduct those different tests and campaigns. The lab planning puzzle is quite complex because we're looking at different demands and priorities, different commitments that we need to take in consideration on due dates, multiple requests from different sources. We have different procedures, methods, recipes that need to be created or managed or tested against. And we have different lead times according to each one of these, as well as different equipment availability, whether it's lab equipments, whether it's do we have the right capabilities, what's our maintenance schedule look like for that equipment in the lab, and do we have the right consumables and materials available to do the testing itself, to ensure that those are available in all of that. And do we have a proper workflow, as Stephen had mentioned before? Is the test status up to date? Do we have hazards that are accounted for that we need to test for? All of these create a complexity that typical manual planning and scheduling processes are ill-equipped to handle, or if you are handling it in a manual fashion, clearly can become a significant bottleneck in a company's ability to achieve on-time delivery, quality, and avoid being the bottleneck in the process. And let's talk like a very basic, to put it in more context, let's take a very basic scheduling example and give you an idea how tough that is. So let's say we have 900 single tests to perform. In each test, we have 3 alternatives. You may have 30 analysts now to use against testing all of that. So the total number of potential schedules, is 10 to the power of 2,699. That's significant. The complexity and the options, how do you manage that in a manual environment? How can you best optimize that schedule to meet your business goals and also to meet your lab schedules? And that's where a real-time scheduling solution comes into play. So we're going to talk about a lab scenario and give you a picture of how we go about that. And in the lab scenario, we're going to just step you through a typical use case workflow within the lab. So starting with generating the lab schedules, looking at a what if scenario against my finite resources and look at how I can drive the lab execution against specific priorities and do what if scenario analysis to optimize that against all my lab and production activities, because the lab is not always disconnected from production. Sometimes you may be doing in quality checks as part of the lab environment. So let's talk about how we integrate the scheduling optimization with the unified lab that Stephen had talked about before. What we're going to show here is within the unified lab, we're going to set up our process definitions, our lab requests and work orders. We're going to do scheduling optimization throughout the process here. So taking those work orders, taking unreleased work orders with process definitions and shoot them into our scheduling optimizer. And then we're going to optimize that and then take information of that detailed schedule, both the start, end dates, start times, the resource assignments, the equipment assignments, the lab techs, and send that back over into our lab workflow for dispatching. As that lab is executing, we take those events and we look at the start, the completions, the closed events, and update our scheduler, which then also helps us get visibility as to the consumables and how that's happening along the process. So I have visibility now of what's actually executing in my lab, how well I'm optimized, and optimizing across the people, the processes, the materials, and the equipment in the workflow. So let's take a quick look at that.
So we're going to take a look at a test here. Specifically in the lab, we're going to look at a formulation test, basically a robustness study. And in this particular case, we're showing the integration between the lab and our finite planning and scheduling. Within the context here, we're going to basically go through a simple task setup and workflow, and then use the finite scheduler to optimize that schedule against resources, both equipment and people, and maintenance. And we're going to take that information back, and we're going to then finish out our plan within our digital lab environment. So let's get started here. So as you can see, I've got a formulation stability study here. This is all the parameters I'm going to need to use for the particular test. And I have my different formulation variants, temperatures identified, as well as giving indications as to what's going to be required as far as test methods, ingredients, and time points. Now in the digital lab, I have now taken that and developed my task plans and see that there's several tasks, plans, and preparation times required for the test. I have the task plan, for example, here where I'm identifying, preparing the bottles, the variants, going through and seeing that I have preparation activity that needs to be done to produce batches for each of those different variants. So I'm preparing the test batches to be conducted. Within the workflow here, as you can see, this is all taken from our master recipe, how to make the formula, as well as identifying the different recipe requirements like pieces of equipment that are used in the test. From here, I'm now going through and looking at my second task plan, which contains the testing time and the number of different test methods and tasks within that test itself. I go through and I may select, for example, here a particular instance that shows me the test methods, which are also available from master recipes. It uses a specific HPLC method type, and then each test method is used by a stability time. Those points are linked in as well. From here, I can take all the tasks and I can then schedule that within my finite planning and scheduling tool. As I go in here, I now have the 4 task plans which have been imported into my finite scheduler. The due dates are shown as red endpoints, and as you can see here, each endpoint and task has a different time interval associated with the test itself. The task resource view, as you see here, is used to schedule both equipment and people, and I can expand that and see the different aspects associated with both the pH meters and the people that'll be assigned to do the tests. We can expand it to show each task and the assigned resources with that. Within the scheduler, I can also begin to pull the tasks and set it against the specific people and the equipment. I can see all the details associated with the resources committed to performing the test. And then I can also review the people that are required with the right skill sets associated with those tasks. So I can view the skills associated for a particular person, for example. I may want to reassign a particular test. Maybe they're not available or don't have the right skill sets. And then I can also identify the right skill sets and have the right people available. So it's also doing workforce scheduling within your lab. As you can see here, I can readjust that and not just take into account the resource skill availability, but also their availability based on their timing within the lab. In addition to that, as I go through and look at all my constraints, I can look at whether there's indications of constraints that may be related to vacation. Other constraints can be brought in that is associated also with equipment. In this case, I'm looking at a pH meter for the task that's required for the task. But I also can look at scheduled maintenance periods that is associated with that piece of equipment. And so here I may see that my task is going to be delayed by a maintenance or availability of that pH meter. And so we can automatically reassign equipment that's associated with the task and better optimize that and bring that together. So now I can take my stability study, optimize that so that I am meeting my schedule, and as you can see here, I'm making the adjustments within the schedule itself. I can save that, and then I bring that back into my overall lab manager that brings all those resources and equipment that's assigned. So back within our unified lab manager, the technician can now access all those tasks that have been assigned. I can perform the tests, and as I go through here, you'll see that I have my workflow continues where now the test method task measures the pH meter assigned brings the data in, the readings taken, and the technician can complete their overall task and have that be completed on an on-time basis. So this is just one very simple example on how you can digitize your lab environment under a finite schedule and take several options in order to optimize the lab according to whatever priorities that you have associated with them. What I haven't shown you is some of the other aspects that you can optimize on. So you may want to optimize based on different priorities. So you may have several different tests going on for different products, different formulas, and you can look at that holistically and then determine which resources and which equipment need to be available for which types of tests, which can then be driven and then drive your priorities within your overall lab environment. So with that, let's take a look now at some of the benefits that this type of solution can give you and some examples.
So you saw a quick view of one example on how you can best optimize your lab scheduling for consumer packaged goods. And just as a quick summary, what are we delivering with that? Well, first off, we're delivering optimization through scheduling and load leveling, multi-levels of scheduling in addition to that. You have interactive modification of the schedule itself, and you get clear visibility of where you're at in the process, both with alerts on on schedules that are not in compliance, schedules that are on time, schedules that are at risk. And so it's very easy to understand, and you now have that availability at your fingertips so that you have the ability to react and be more sustainable in your lab execution. It's also collaborative. I didn't show that as much in the demo, but multiple planners can work simultaneously, and it's configurable for different user rights and profiles, and all the different constraints we talked about before can be accounted for. You can add additional constraints depending on where the constraints you're starting to see your team run against. And the simulation capabilities have been developed over several years, and where we're able to save and compare multiple simulations, run those what-if scenarios in the process. So driving lab agility is important, and doing it through smart planning and scheduling is the way forward. And so what we're delivering here is a new tool to help that is more automated, dynamic, has certified integrations, also with other LIMS, with the ERP, also can extend into your production environment, and is collaborative, and as you can see, has a very easy interactive UI that collaborates with your lab workflows as well. So just in summary, the value of a unified lab and an optimized scheduling approach really is about optimizing your laboratories and leveraging all your resources, your internal resources, to improve time to market. And what we see as a result from our customers is a significant reduction in planning time, improving flexibility and responsiveness, and also reducing the lead time that's necessary to bring products to market, but certainly reducing lead time within the lab, whether it's for a new product or whether it's for inline quality testing. We also have customers coming back to us about their service level increases, some upwards to a level of 20%, and a decrease really in compliance risk as well, and increases in productivity. The paper elimination in this process is important and really kind of the first step in digitization, but optimizing that process really takes us to the next level of where the next generation of lab needs to be. And that includes automating those processes, streamlining the experiment creation in the process, the reporting that's required as part of the lab as well. And then lastly, we no longer have disparate sources of data that run the risk of manual error being entered in or data synchronization being an issue. So as a result, now we have data integrity that can be achieved from start to finish within the process. And from a regulatory compliance standpoint, that's very important and helps us improve our overall data traceability. So with that, I want to thank you for your time. And again, you can contact us at Dassault Systems for more information. You can contact myself or Stephen. And with that, we'll end the session and enjoy the rest of your day. Thank you.
Thank you very much.